Welcome to this explainer. Let's just jump right in. Today, we're looking at how to totally transform your engineering workflow. And look, we are not just talking about writing a quick script a little bit faster. No, we're talking about evolving from simple, basic code generation into a massive, fully automated AI software factory using Claude code. If you've been feeling like AI is, just a neat autocomplete trick, well, get ready because we're about to completely re-architect how your team builds software. It's a real game changer. Here's our roadmap for today. We'll start with a big picture paradigm shift of the AI-Native SDLC. Break down the 6 core primitives you'll need, talk about treating context as a budget, walk through a live multi-agent pipeline, and finally, wrap up with human gates and your phased rollout plan. All right, section 1, the AI-Native SDLC, or shifting the paradigm. Let's see how this builds a totally new mental model for software engineering before we even touch a line of code. So, is AI just for code generation? Well, the biggest mistake organizations make right now is treating AI like a fancy autocomplete. Honestly, if you're only using AI to type boilerplate a little faster, you're effectively treating a supercomputer like a typewriter. You're missing out on the massive ROI of automating the entire software development lifecycle. We really need to zoom out, look past the IDE, and think about the whole pipeline, from gathering requirements all the way down to production deployment. Think about the leap from level 1 to level 4. At level 1, you're writing code with an AI assistant kind of peering over your shoulder, helping you out with a line here or there. But at level 4, specialized AI agents are actually orchestrating and executing the entire pipeline, while humans step up to act as architects, reviewers, and product owners. You're not just a coder anymore, you're literally the factory manager. Moving right along to section 2, the 6 core primitives. These are basically your essential factory tools. Now, the biggest trap teams fall into is putting behaviors in the wrong layer. It's like trying to stuff a complex, reusable workflow into one giant bloated prompt. Please don't do that. Instead, we have distinct tools for distinct jobs. Check this out. If you need repeatable knowledge, you build a skill. Want to automatically enforce a rule like blocking a bad commit? You use a hook. To connect with external tools, say pulling data from Jira or GitHub, you use MCP servers, which stands for Model Context Protocol. When you need heavy parallel lifting, you spin up subagents. For coordinating across multiple repos, you deploy agent teams. And finally, to distribute all of this genius to your team in a single command, you wrap the whole shebang in a plugin. Keep these layers separate, and your factory will run like a dream. Now, what really stands out here is the concept of subagents. These are your absolute biggest lever for parallelism and cost savings. Instead of doing all the messy, noisy work in your main chat window, your main agent spins up an isolated worker. Thanks to Git work trees, these subagents can safely edit, say, 4 to 8 concurrent branches at the exact same time, without ever triggering a nightmare merge conflict or clobbering each other's files. The subagent just crawls the codebase, runs the tests, does the heavy lifting, and then reports back a clean summary. It is incredibly efficient. Okay, section 3, context as a budget, and the split file architecture. Let's dive right into the brain of our factory. I really want you to burn this quote into your mind. Context is a budget, not a free resource. A bloated memory file silently taxes every single interaction. Think about it. Every time you ask the AI to do something, it has to reread everything in its context window. If you stuff your entire company history and every single coding guideline in there, you're just setting money on fire, burning tokens, and crowding out the actual task. We absolutely must treat AI context as a strict budget. To pull that off, we use what's called the split file architecture. We keep the main file, Claude.md, incredibly tiny, just always on pointers and absolute non-negotiables. Then, we push all the bulky stuff out. We put the big picture boundaries in architecture.md. We log the why behind past choices in decisions.md. And crucially, we use a status.md file as our working memory, updating it at the end of every single session. The AI only grabs these extra files when it actually needs them. By keeping this context lean, the benefits are huge. We save massive amounts of compute tokens, sure, but more importantly, we force the AI to focus solely on the exact requirements of the current task. Actually, scratch that, it's not just about focus, it's about accuracy. A focused AI is an accurate AI. Progressive disclosure is the name of the game here. Let's jump to section 4, the multi-agent pipeline. This is where we wire it all up and see the assembly line in action. Here is your pipeline doing its thing. First, the AI generates the product requirement document and outlines the architecture. Next, it logically breaks those stories down into API, database, and front-end tasks. Step 3 is where the real magic kicks in. The main orchestrator spins up multiple subagents to tackle the front-end and back-end concurrently, based exactly on the API contracts they just agreed on. And, finally, a dedicated reviewer subagent, running on a totally fresh context, inspects the code. It's a literal assembly line running at machine speed. Absolutely wild. But wait, how do we keep this lightning-fast assembly line from, breaking production? Well, that's where hooks come in. They act as automatic safety rails. A pre-tool use hook instantly blocks the AI from reading your secret .env files. A post-tool use hook formats and lints your code so you never have to argue about syntax again. And a stop hook can literally require your test suite to pass before the AI is even allowed to finish its turn. You don't have to remember to run the tests. The factory just enforces it automatically. Moving into our final part, Section 5, Human Gates and Rollout. Let's talk about the control center. Remember, full automation does not mean hands-off. The key takeaway here is AI does the work, humans own the gates. The AI does all the heavy lifting, but you provide the strategic oversight. Your job transitions from typing syntax to validating direction. You are the final authority. And because you're the authority, you must never ever remove these 4 human gates. Number 1, PRD sign-off. A wrong requirement makes everything downstream wrong, just faster. Number 2, architecture sign-off, to ensure your module boundaries are respected. Number 3, security triage. Humans must always review high-severity vulnerabilities. And number 4, production deployment. Hey, go ahead and automate your dev and UAT environments, but keep a human finger on the prod button. These gates are literally the only things protecting you from a highly confident mistake shipped at lightning speed. So how do you actually implement this without overwhelming your entire engineering department? You use this specific 5-phase rollout plan. Seriously, don't try to do this all on day 1. Phase 1 is just about establishing simple foundation skills and a clean Claude.md. Once that's stable, move to Phase 2, locking things down with your enforcement hooks. Only in Phase 3 do you start delegating to those parallel subagents. By Phase 4, you bundle it all into a single command plugin for the whole team. And finally, Phase 5 is where you scale to multi-repo agent teams. Build it layer by layer. If you're sweating about the cost of running all these AI agents, look at this number right here, 70. By properly leveraging cheap, fast models like Claude Haiku for grunt work like searching logs and isolating tasks and subagents, optimized enterprise teams have slashed their token bills by 70% without docking quality. Keep the expensive reasoning models for the complex architecture and just use the fast, cheap models for the heavy lifting. So, as you look at your team's workflow tomorrow morning, I want you to ask yourself this question. Are you just building code, or are you building an AI software factory? It is time to stop treating AI like a glorified autocomplete and start architecting your Level 4 multi-agent SDLC. The tools are here. The primitives are defined. It's time to build the factory. Thanks so much for joining me on this explainer. So, what will you build first?